Dear student, in this video we will learn chapter number 2 real numbers. Practice set 2.2. If you have not subscribed my channel, please subscribe it today itself. Let's start. What are rational number? The number of the form m upon n are called rational numbers. Here m and n are integers, but n is not a zero. So what is a rational number? It is a fraction. It is a fraction. It is in the form of m upon n, where numerator and denominator of this fractions are integers, but denominator should not be 0. Let's see some examples over here. Here we have the first example, minus 25 upon 3. It is a fraction. You can see here the numerator is minus 25, which is negative integer, and denominator is 3. It is positive integer. So here we have a fraction whose numerator and denominators are integers, and you can see that here denominator is not a 0. Therefore minus 25 upon 3 is example of rational number. Similarly 32 upon 3, it is also fraction, and you can see the numerator of this fraction is 32, which is positive integer, and denominator of this fraction is 3, which is positive integer. It means numerator and denominator of this fractions are integers and denominator is not a 0. Hence 32 upon 3 is example of rational number. 10 upon minus 7 is also a rational number. Minus 4 is also rational number. Just now I said that rational number is a fraction. Okay, you can see minus 4 is not a fraction, but minus 4 can be written as minus 4 upon 1. If I write minus 4 as minus 4 upon 1, the meaning of the number will not change, the value of the number will not change. Okay, now you can see it is a fraction, and here the numerator of this fraction is minus 4, which is integer, and denominator of this fraction is 1, which is also integers. That means numerator and denominator of these fractions are integer and denominator is not a 0. Hence minus 4 is example of rational number. Similarly 0 is also a rational number. What are irrational number? The number which is not a rational is called an irrational number. It means if the number is not in the form of m upon n, then number is known as irrational number. The decimal form of irrational number is non-terminating and non-recurring. The square root of numbers that are not perfect square are irrational numbers. Let's see some examples. Here we have square root of 2, and you can see that 2 is not a perfect square, and the decimal form of root 2 is 1.4142 dot 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 dot. It means the decimal form of root 2 is non-terminating, means never ending, and non-recurring. Okay, therefore root 2 is known as irrational number. Similarly here we have square root of 3, and you can see that 3 is not a perfect square, therefore root 3 is also irrational number. Root 5, and you can see that 5 is not a perfect square of any of the number, therefore square root of 5 is also example of irrational number. Here we have question number 1. Show that 4 root 2 is an irrational number. Let's see the solution of this question. Let 4 root 2 be a rational number. Okay, what is a rational number? A number in the form of m upon n. Okay, where m and n are the integers and n is not a 0. It means 4 upon root 2 equals to m upon n, where m upon n is rational number. Okay, I have assumed that 4 root 2 is a rational number, and here m upon n is rational number. Okay, now we will shift 4 to that side of equal to, so we will get here root 2 equals to m upon 4n. Okay, m upon 4n, and you know that m upon n is a rational number, right? And I'm multiplying m upon n with 1 upon 4, right? And a 1 upon 4 is also rational number, right? And when I'll multiply rational number with a rational number, we will get here 4 upon 4n, right? Which is also rational number. So m upon 4n is a rational number, and you are saying that m upon 4n is rational number and it is equals to a rational number. Okay, so now m upon n is a rational number, then m upon 4n is also a rational number. Just now I had given you example, if you multiply m upon n with 1 upon 4, you will get m upon 4n. So when you multiply rational with a rational, you will get a rational number. Okay, then root 2 is also rational number. If you are saying that m upon m upon 4n is rational number, okay, then definitely root 2 will also rational number, okay, because both are equals to each other. Okay, but it contradicts the fact that root 2 is an irrational number. We know that root 2 is not a rational, it is an irrational number. Okay, so our assumption is wrong. Okay, since root 2 cannot be equals to m upon 4n, irrational number cannot be equals to rational number, therefore our assumption is wrong. Hence 4 root 2 is an irrational number. Here we have question number 2, show that 3 plus root 5 is an irrational number. Okay, we will assume 3 plus root 5 as a rational number. Okay, that means 3 plus root 5 equals to m upon n, where m upon n is a rational number. Okay, it is a rational number. I have assumed it that 3 plus root 5 is equals to rational number. Now I will shift 3 to that side of equal to. Okay, so we will get here root 5 equals to m upon n minus 3. Okay, now here m upon n is rational number and 3 is also rational number, and if I'll subtract rational number from rational number, we will get here rational number. It means m upon n minus 3 is a rational number. Okay, because subtraction of two rational number is rational number. Okay, so now m upon n is a rational number, then m upon n minus 3 is also a rational number. Okay, it means root 5 is also a rational number. Okay, because m upon n minus 3 is rational. If m upon n minus 3 is rational, so definitely root 5 will also rational number, because rational number will be equal to a rational number. But it contradicts that root 5 is an irrational number. Okay, we know that root 5 is not a rational, it is a rational number, but I am getting root 5 as a rational number. That means root 5 cannot be equals to m upon n. Okay, root 5 cannot be equals to m upon n minus 3. Therefore our assumption is wrong. Hence 3 plus root 5 is an irrational number.
Let us see today how to represent root 5 irrational number on the number line. Okay, so the first step, we'll draw a line. We draw a line, say line L. Okay, first step, draw line L. On this line, mark a point here. This is point. Okay, you can mark it at 0, and this is point O. Then on the right side, okay, we are going to represent root 5. So on the right side, you can, by using the scale, okay, you can take distance. You can take, now see, you can take distance as this is 1 inch, 2 inch. Okay, so you can take the distance. Here you will take distance. This is 1 inch and this is 2 inch. Okay, and mark this as 1 and this is 2. Okay, 1, 2, and this at 2 you are going to mark point A. So on the number line we have taken distance 1, 2, we have marked point A. Now you are going to draw perpendicular here by using protractor at this point. By using protractor, draw 90 degree. You can do that. Draw 90 degree at this point A. Okay, then after this we are going to take 1 unit distance. Here we will take this unit distance, 1 unit. You can see from 0 to 1, that unit distance is taken, 0 to 1. Okay, 1 unit distance only taken, and from this point A we cut an arc. I repeat, we have taken only the unit distance, 1 unit we have distance, cut the arc. Name this point as point B. This is point B. And now draw seg OB. Draw seg OB. And this OB, okay, so this OB we will see now. So in right angle triangle OAB, in right angle triangle OAB, this OB the hypotenuse, so OB square equal to OA square plus AB square by Pythagoras theorem, and therefore we get OB square. Now see OA. Now this OA distance is 1, 2, 2. It is 2 square plus 1 square. So you get OB square equal to 2 square is 4 plus 1. OB square 4 plus 1, 5. And therefore taking square root, so we get OB equal to root 5. Okay, we get OB equal to root 5. Now this OB we get root 5, and this root 5 we have to represent on this line now. Okay, we have to represent on this line. So we take the rounder and keep it on point B. Take this distance. Okay, you can see this distance of O to B you take, which is root 5, and from here you cut an arc. You can see that you cut an arc, and this is root 5, which is, you can mark point B. Okay, so point B represent, so point B, okay, sorry, point you can mark here C. Okay, this point you can mark it as point C. So point C represents root 5 on number line. So this is what we have represented, root 5 on the number line.
Here we have question number 4. Write any three rational numbers between the two numbers given below. The first one is given here 0.3 and minus 0.5. And I have to find out here three rational number between 0.3 and minus 0.5. Let's see the solution of this question. Between 0.3 and minus 0.5, we have many numbers. Okay, you can see here 0.2, 0.1, minus 0.1, minus 0.2, minus 0.3, minus 0.4 are the numbers, are the rational numbers between 0.3 and minus 0.5. Okay, if you want, you can solve this also to know the rational number between these two. What you have to do, you have to add these two number. Okay, 0.3, okay, plus minus 0.5. Okay, we'll add this two number and the sum of these two we will divide by 2. Okay, so 0.3 plus minus, so what we'll get here, 0.3 plus minus minus 0.5 upon 2. Okay, and 0.3 minus 0.5 gives us minus 0.2 upon 2, and if we'll divide minus 0.2 by 2, we will get here minus 0.1, and you can see that number is over here. Okay, so the number between these two is minus 0.1. The same way now you can add minus 0.1 and minus 0.5 and you will divide it by 2. Okay, in that way you can find out all rational number between those two numbers. Okay, so three rational numbers between 0.3 and minus 0.5 are 0.2, 0.1 and minus 0.1. Similarly, here we have the next question, minus 2.3 and minus 2.33. Let's see the solution of this question. Minus 2.3 can also be written as minus 2.300. Okay, and minus 2.33 can also be written as minus 2 minus 330. Okay, what I said, minus 2.3 you can write as minus 2.300. The meaning of the number will not change, and minus 2.3 you can write as minus 2.330. So the rational number between minus 2.3 and minus 2.33 are minus 2.301, minus 2.302 and minus 2.303. So many numbers are there between these two. So the three rational number between minus 2.3 and minus 2.33 are minus 2.301, minus 2.302 and minus 2.306. Now we have to find out three rational number between 5.2 and 5.3. 5.2 I can write as minus 5.2 can be written as 5.20 and 5.3 can be written as 5.30. Okay, so the number between 5.20 and 5.30 are 5.21, 5.22, 5.23. So we have many numbers between these two. So three rational numbers between 5.2 and 5.3 are 5.21, 5.25 and 5.26. Now here we have the next question, minus 4.5 and minus 4.6. Okay, which we can write as minus 4.5 can be written as minus 4.50 and minus 4.6 can be written as minus 4.60. Okay, minus 4.5 I can write as minus 4.50 and minus 4.6 I can write as minus 4.60. You can add number of how many zeros you want after the given decimal number. The meaning of the number will not change. Okay, so you will get minus 4.51, minus 4.52, minus 4.53, minus 4.54. So many numbers you will get. So the three rational numbers between minus 4.5 and minus 4.6 are minus 4.51, minus 4.52, and minus 4.53.